Hello. Today we're going to talk about perpendicular lines. So we're going to start with a warm-up and then make sure you have the perpendicular lines notes with you, okay? So here's a warm-up problem for you to do. Pause the video at this point, work on this problem, and then when you are finished, you can unpause it and we'll go over it together. All right, so we want the equation of a line parallel to y is equal to 5x minus 9 going through that point, 2 comma negative 7. So remember, what do we know about parallel lines? We know that they have the same slope, and we know that they have different y-intercepts. So we know this is y equals mx plus b. So we know that the slope is going to be 5. And we know that the y-intercept is not negative 9, right? But we also know that the line has to go through this point, 2 comma negative 7. And that gives us an x and a y value. So we can plug all this information into y equals mx plus b. So our y value is negative 7, our m value is 5, our x is 2, and we need to find b because we need to find this new y-intercept, right? So to solve for b, I can just multiply the 5 and the 2 together. So I have 10 plus b, and then solve for b. Subtract 10 from both sides, subtract 10, and b is equal to negative 17. Now I can take the slope that they gave me and the b that I just found and write it all together as y is equal to 5x minus 17. So there's my equation that's parallel to this line and going through this point. Now you're going to see today we're going to talk about perpendicular lines, and this process is super similar. So we're going to start with a perpendicular lines investigation that's going to be really similar to what we did with parallel lines yesterday. And then we're going to talk about how we write equations of lines that are perpendicular. And then we're going to finish with, I'm going to give you some equations and you're going to tell me if the lines are parallel, perpendicular, or neither. All right, so the first page of your notes is this perpendicular lines investigation. So you're going to follow the directions. Each graph below contains pairs of lines, and you're going to calculate the slope of each line. And then you're going to answer the questions at the bottom. And if you remember perpendicular lines, let's first just quick talk about what perpendicular lines are. Perpendicular lines meet at a 90-degree angle. That's like the corner, think of like a corner of a piece of paper, or like a lot of times the corner of a square or rectangle or something. That's that 90-degree angle. So those two lines are perpendicular, all right? And a lot of times the symbol for perpendicular lines actually looks like an upside down T. So that symbol I just drew there means that two lines are perpendicular. So if I look at most of these, I have that like squared off corner or whatever. They're meeting at a 90-degree angle, so they're perpendicular lines, okay? And so, we're going to investigate what happens to the slopes of these perpendicular lines. So you have to find the slope. Just a quick reminder, in order to find the slope, we're going to count rise over run. You're going to pick 2 points that are on the line. So let me start with letter A, line 1. I have to be really careful and make sure I can find exactly where these lines are going through the grid marks. So if I want to go, you can pick any 2. Doesn't have to be the ones that I picked. But if I want to find slope, I'm going to count rise over run. So I can go down 2, and then I can go to the left 1. And so if I put that together, I went down 2 and to the left 1. A negative over negative is a positive, and 2 over 1 is equal to 2. So this is for this line 1 right here. So the slope of that line 1 there is 2, okay? So now you're going to take your time and you're going to find the slope for each of these other lines. So first you're going to do line 2 in letter A, and then lines 1 and 2 for all these other ones. So you're going to do 12 total slopes. You're going to find 12 total slopes, okay? So pause the video here, count rise over run for all 12 of those slopes, and then when you unpause, we'll talk about it. Okay, so here are the slopes that I came up with. I know this is a little hard to read, but hopefully you can kind of see it. So letter A was, line 1 was 2, like we just found. Line 2 was -0.5, et cetera, et cetera, et cetera. And if I look at these really carefully, all these lines are perpendicular except for these down here in letter E. They cross, but they're not really perpendicular. They don't meet at exactly a 90-degree angle. So what's the pattern that you see with all these other lines, all these other slopes, except for letter E? So first of all, let me answer this question here. Do all slopes fit the pattern? No. And letter E are not perpendicular. Remember that upside down T means perpendicular. All right, so if I look at all the other pairs of slopes, I want you to notice that if I think of like I'm going to start at letter A, line 1, the slope is 2, but really it's like 2 over 1, because 2 is 2 over 1, right? If I flip the 2 over 1, it becomes a 1/2. But also, line 1 had a positive slope, and line 2 had a negative slope. Look at letter B, 3, or in other words, 3 over 1. Flip it, becomes 1 over 3, and if I change the sign, it changes to a negative, right? So positive 3 over 1, negative 1/3. I'm going to jump down to D because C is a little bit more tricky. We'll do that one last. But if I look at D, negative 4 over 1, so it's negative 4 over 1, flip it, becomes 1 over 4, and change the sign. Now this one's a positive 1/4. And then line F, 1 over 1, it's positive. Flip it, it's actually still 1 over 1, but we change the sign, and that's a negative. I know it's kind of hard to see. Let me jump back to C, letter C. If I look at this slope here, this is 0 over 1. Flip it. If I flip it, it's 1 over 0. Change the sign, make it negative. It doesn't matter if it's positive or negative. If it's 1 over 0, it's undefined, right? So the pattern is that the signs are different, or in other words, like opposite. So like one's positive and one's negative. But also the fractions are flipped. Like the numerator went to the denominator, denominator to the numerator. So down here at the bottom, if we want to write a conjecture about the relationship between the slopes of perpendicular lines, I'm going to say if lines are perpendicular, the slopes are what we call opposite reciprocals. Reciprocal is a tricky word to spell. But opposite means we switch the sign. So like one's positive, one's negative. And reciprocals means we flip the fraction. So in other words, we have to flip the fraction and switch the sign, okay? Let's formalize this. Let's look at the definition of perpendicular lines, and you are going to want to write this down in your toolkit, or on your note sheet if you haven't done so already. But perpendicular lines are lines that intersect at a 90-degree angle, and we call that a right angle. And if you look at the example here, like the graph, when you draw this little box in here, it means that those lines are perpendicular. And I already showed you the symbol for perpendicular lines, looks like an upside down T. And we just saw in our investigation that their slopes are opposite reciprocals. And remember, that means that they're going to have different signs and the fractions are going to be flipped. So flip the fractions. Okay, so if I look at my slopes, y equals mx plus b, the slope of this line is -3/2. So the other slope has to have the different sign. So this one's negative, this one's positive, right? And we flip the fraction, it becomes 2/3. And if the slopes are opposite reciprocals, we know that the lines are going to be perpendicular. And we're going to use that fact to write equations of lines. So I'm going to leave this on here for a second. Make sure you have this written down. You can pause the video here if you need to or want to. All right. So before we get into writing equations, first I want to talk more about opposite reciprocals, right? So opposite reciprocals, remember, you switch the sign, you flip the fraction. So if I give you a slope of 2 and I want you to find the opposite reciprocal, so first of all, I'm going to use this symbol for, I want the perpendicular slope, right? That's all that means. This is like 2/1. Flip the fraction, becomes 1/2, but I also have to switch the sign. It was positive to begin with, so I got to make it negative. All right? So -1/2. Number 2, this is -7. I got to really make it into a fraction. So if it's not a fraction already, put it over 1. And if I want the perpendicular slope, I have to flip the fraction so it becomes 1/7 and change the sign. It was negative to begin with, so this is going to be positive 1/7. Make sense? Number 3, the perpendicular slope, I flip the fraction, change the sign. So it's negative, I need to change it to a positive, and 2/3 flips to 3/2. So positive 3/2. And then number 4, again, perpendicular slope, change the sign, flip the fraction. It was positive 1/5, so it becomes a negative, and we flip it, so it becomes 5/1, and that's really just -5. All right? So now you did a little bit of practice with just finding opposite reciprocals, right? So now we have that part down. We're going to actually write equations. So we're going to write the equation of the line that's perpendicular to this line here, y equals 3x plus 11, and we want it to pass through the point 12, 5. All right, so remember, perpendicular lines have slopes that are opposite reciprocals. So the slope of this line is 3, right? This is like y equals mx plus b. So if the slope of this line is 3, the perpendicular slope is what I have to find first. Remember, I need to switch the sign and flip the fraction. So it was positive 3, and that's like 3/1. So I need to make it a negative 1/3. So my new slope is going to be negative 1/3. And now I need my new line to go through this point here. And this is like an x and a y. So I'm going to take all this stuff and plug into y equals mx plus b. The y value they gave me was a 5. The m I just figured out is negative 1/3. The x that they gave me was 12, right? And I want to find b. So in order to find b, I have to solve. I need to multiply this negative 1/3 times 12, and that's negative 4. Solve for b. We're going to add 4. 9 is equal to b. Now, again, I need my equation. This isn't good enough. I can't just solve for b and be done. So I'm going to take the m that I just found and the b I just found and put it all together. Y is equal to negative 1/3 x plus 9. That's my equation, perpendicular to that original line they gave me. So there's my final answer, okay? So just like before, I find the slope, and then I use y equals mx plus b to write the equation of the line going through the point that they gave me. All right, here we go. Let's try another one. So example number 2, we want the slope-intercept form of equation of a line that's perpendicular to this equation here and passing through the point 6, 7. So remember, perpendicular lines, we have to flip the fraction, change the sign. So negative 3/2, change the sign, it becomes a positive, and we have to flip it so it becomes positive 2/3, right? And now we want it to go through this point, 6, 7, and that point is like an x and a y. So x is 6, y is 7. So now I'm going to take my x, my y, and my m and plug it into y is equal to mx plus b. So y is 7, m is positive 2/3, x is 6, and we're trying to find b, right? So now I've plugged everything in. I'm just going to take a couple minutes and solve for b. Use your calculator if you need to, but this is like 6/1 when we multiply 2/3 times 6. Remember, we multiply with a fraction and a whole number. We multiply the numerators and the denominators. So this will be 7 is equal to 6 times 2 is 12. 3 times 1 is 3. Reduce that. That's 4, right? And then solve for b. So we're going to subtract 4. B is equal to 3. So my equation is y is equal to 2/3 x plus 3. There you go. So that's my equation perpendicular to the original line going through that point 6, 7. All right, so now you've done 2 example problems. You have a whole bunch of you try problems. I just have 3 of them here. You're going to do these 3, and then you're going to continue doing the rest. So if you want, you can just pause the video and work on your own. But if you want me to go through, I'm going to quickly go through a few more examples just in case you need some more practice, okay? So let's jump into number 1. We want the equation of a line perpendicular to this equation here. So perpendicular slopes are opposite reciprocals. Switch the sign, flip the fraction. So this is like negative 2/1. So we're going to make it a positive, and we have to flip the fraction. So it's going to be a positive 1/2, right? That's my slope. And then they gave me this point, 8, 8. So remember, I take all this stuff and plug into y equals mx plus b. The y value they gave me was 8. The slope I figured out is 1/2. The x is 8. And now I'm going to solve for my y-intercept or b value. So I have to multiply 8 times 1/2. That's like 8/1. 1 times 8 is 8. 2 times 1 is 2, right? Or you can just use your calculator. Now you got to reduce. 8 divided by 2 is 4. So it's really like 8 is equal to 4 plus b. And now solve for b. You're going to subtract 4, and you get 4 is equal to b. So put it all together. Y is equal to 1/2 x plus 4. There's your equation. All right, let's try number 2. So we want the equation of a line perpendicular to y is equal to negative 5/6x minus 3, and the y-intercept is the point 0, 11. So they made it kind of easy for you. Remember, 0, anything, that's your y-intercept. This is your b. So I'm not going to have to do anything to solve for b. They just gave me b, right? But I do have to think about the slope. So perpendicular slope, I got to flip the fraction, change the sign. It was negative 5/6. It now becomes positive 6 over 5, that's the opposite reciprocal. Now I have an m and I have a b. So y is equal to 6 over 5x plus 11. But guys, guess what? Even if you forgot that 0, 11 is your b, you could have, I'm going to show you, you can still plug in for x and y, and you'll get the same thing. Like y is equal to mx plus b. So 11 is equal to 6 over 5 times x is 0 plus b. 6 over 5 times 0 is just 0, right? So it's just 11 is equal to 0 plus b. And then 0 plus b is just b. So 11 is equal to b. So you could plug in the 0 and the 11 and solve for b, and you still get the same answer. All right, let's try 3. So the equation of a line perpendicular to y equals 3 over 8x minus 3. So perpendicular slope, change the sign, flip the fraction, and we want it to go through the point 0, 12, right? So hopefully you recognize 0, anything. Oh, they're giving me b. This is my b. Or, like we did up above in number 2, you could plug in. This is x, this is y, and you're going to plug into y equals mx plus b. But even if you do that, so even if you plug in y equals mx plus b, 12 is equal to negative 8 over 3 times 0 plus b. But negative 8 over 3 times 0, like we said before, is 0. And so we have 12 is equal to b. So putting it all together, y is equal to negative 8 over 3x plus 12. There's my equation. All right, so you have a bunch more you try problems, and kind of like what we did with parallel lines, sometimes your equations given are going to be in y equals mx plus b form, and sometimes you're going to have to take a minute and solve it for y to come up with the slope, and then find the opposite reciprocal. All right, so pause the video here, work on those you try problems, and then I want you to come back because we're going to do the last couple together. So on the back side, we're going to determine whether each pair of lines is parallel, perpendicular, or neither, okay? So in order to do that, we need to look at slopes, right? We know that parallel lines have the same slope. We know that perpendicular lines, the slopes are opposite reciprocals. And neither, that would be if the slopes don't really have a relation to each other. So if your slopes are like 4 and 2, or like negative 7 and 0, then we would say they're neither. They're not the same. They're not opposite reciprocals. So that means the lines do cross, but they don't cross in a 90-degree angle. So we got to find the slope. So if I look at this, number 1, the slope of number 1 is 3. Y equals mx plus b, right? The slope of number 2 is the second equation, I should say, negative 1 over 4. So look at those. Are they the same? Nope. Are they opposite reciprocals? Well, let's think about it. 3 is 3 over 1. If I flip it, it becomes like 1/3. They're not opposite reciprocals, so this is neither. They're not parallel. They're not perpendicular. They're neither. Try number 2. So number 2, this slope is negative 1 in front of that x, right? This slope is positive 1. Well, if I look at the first one, so negative 1, put it over 1, flip it, it's still 1 over 1, and change the sign. It's positive. And that's what the other equation was. M is equal to 1, right? So these are opposite reciprocals. And that tells me that the lines are perpendicular. Let me try number 3. So number 3, y is equal to x over 3 minus 4. You got to keep in mind, what's the number in front of x always? There's an invisible 1 there, right? So this slope is 1/3. the second equation, the slope is also 1/3, right? If the slopes are both 1/3, they're the same. So if the slopes are the same, that tells me the lines are parallel. All right. In number 4, if I look at this, in number 4, these equations are not in y equals mx plus b. So I can't just read off the slope. So what I have to do is I first have to solve for y. So this first equation, to get y by itself, I need to subtract 2x from both sides. And I have y is equal to negative 2x plus 2. Now y is by itself, so now I can say m is equal to negative 2. All right? And then for this second equation here, again, I have to solve for y. I got to get y by itself. I got to subtract 2x. That cancels. Y is equal to negative 2x plus 5. What's your slope? M is equal to negative 2, right? Negative 2, the lines are parallel. All right, number 5, I'm kind of out of room, so I'm going to do it over here. So again, these equations are not in slope-intercept form. They're not in y equals mx plus b, so I got to put them into y equals mx plus b. So solve for y. We're going to subtract 4x. We have negative 3y equals negative 4x plus 36. And then to get y by itself, divide by negative 3. And you have y is equal to positive, because a negative over negative is a positive, 4 over 3x minus 12. Right? So the slope of this line is 4 over 3. Now let's look at the second equation. So 3x plus 4, y equals 20. I'm just rewriting the next equation. And now I'm going to solve for y to get it into slope-intercept form. So I'm going to subtract 3x from both sides. That cancels. I have 4y is equal to negative 3x plus 20. Get y by itself, so you got to divide both sides by 4. And I have y is equal to negative 3 over 4x plus 5. Right? So the slope here is negative 3 over 4. So my two slopes were 4 over 3 and negative 3 over 4. So let's start with this first one up here, positive 4 over 3, right? Opposite reciprocal of that, switch the sign, it would be negative, and flip the fraction. It would turn into 3 over 4, which is what the slope is on the other equation. So that tells me that these two lines are perpendicular. All right, that is it for perpendicular lines. Thanks so much for watching and have a great day.